Eric, thanks so much for joining us a little bit today. I'd like you to kind of share out for our listeners, what it is that you do and how you got involved in space.
Sure. Yeah, it's great to be here. It's nice to talk to you all. It's funny, I'm not used to being interviewed, so it's kind of a new thing for me, like we talked about, but I appreciate the opportunity. I kind of had an interest in engineering and science since I was young. You mentioned I went to space camp, and that was kind of an early important experience for me. And yeah, just like science fiction interests as a kid was important for me, and just the friends I had as a kid had a big influence on me. We And I guess I got started from my father went to the Air Force Academy. He's a retired Air Force officer, and so he probably got me started on the aerospace interest when I was a child. And he grew up building model airplanes as a child. And we talked about kids living in rural areas who may not have as many opportunities. And my father was one of those. He grew up in a small town in Tennessee, and that was, building model airplanes was how he got his interest in flying and the aerospace industry. And so for me, it was kind of, as a child, video games and puzzles and that type of thing got me interested in engineering. And Kevin and I talked before about Star Trek. I kind of grew up watching Star Trek, and so that was a big inspiration for me.
I saw some of the authors that you mentioned, and I'm an English teacher, in addition to kind of
right.
the work with the students that we have. So I try still to like my biggest introduction to sci-fi was Kurt Vonnegut, right? But Isaac Asimov and Ray Bradbury and some of these authors who've been around forever can still speak so well to even kids today. Do you notice that what was said or mentioned or dreamed about even like in the 1950s even is something that's still kind of slowly coming about? What are your thoughts on that?
Right. No, I agree. It's so a lot of these far-sighted visionaries like the authors you mentioned, and also H.G. Wells, even centuries back, like we're still working on realizing their visions. And so that tells you the far-sighted visionaries like this, they know that vision is going to take a while, and it's but that's, these bold visions are important to think about how things could be different, that things change over time, and that we're not, the world we are given is not the only way that it could be. We can always change things for the better. And I think that's a lot of like the vision in the Star Trek universe is a big part of what inspired me, and as a positive future for humanity in the universe. And so a lot of these authors I know sometimes they're dystopias in science fiction, but we also have a better world in some of these stories. And so that's kind of what got me into engineering.
I mean, science fiction really is futurism, right? With potentially an optimistic spin, especially some of the non-dystopian stuff, right? There is an opportunity to improve some of these problems. We challenge our kids you've got to clean up the mess that we've made, right? I could just start and stop with microplastics in our environment. That's a mess we've made. That is a completely human-made mess that has lots of deleterious effects on all of us and our environment. I'm hoping that the kids we train today will be able to fix some of these problems.
Well,
yeah, for sure.
Oh, go ahead.
No, I agree. I think, it's there's that quote that you can't solve problems with the same type of thinking that created them. And so that I think that's Albert Einstein. But so that's important to encourage people to think differently. And so I think that's what we can always do, something different, and we don't have to accept the world as it is, as it's been given to us. So
tell us how you gave us your background and your inspirations. You end up fast forwarding into a career. So you end up choosing a career path, engineer. What part of engineering? Tell our listeners a little bit about what it is that you ended up doing with this love of space.
Sure. So when I was in middle school and high school, I took part in some science and math competitions, and like the Math Counts program in middle school. I was fortunate to have a teacher who was very enthusiastic about math, and he wanted to challenge us. And so we went to math competitions, and we learned skills like number sense, where you doing mental math is part of those competitions. And so like the numeracy aspects, and also science competitions was a big thing that helped me get into engineering. And so I ended up going to college at Princeton. We talked about, they have an engineering program that I considered that as a first year student at Princeton. I ended up going into a bachelor's in physics, which was kind of combined the technical interest with a variety of interests. I had a variety of interests as a student, and so I found that Princeton was a good school for me because I could pursue different opportunities. And it wasn't, you can take the technical courses, but the humanities, they have the humanities also. And so I found that was important to try different things. They actually require you, at many colleges, they require you to take a variety of courses to get a broad perspective. And I think that's really valuable for helping you brainstorm solutions to problems. So as an engineer, the humanities are important also for that perspective. And so that's one thing I appreciated about college. And it was a great time to try new things, working on my degree. And so I graduated. I worked in the consulting industry for a little while. So not like a non-engineering type career. But then I ended up doing a master's degree later to change careers. And I realized I wanted to get back into the engineering and the technical field. And so I did that. I did a one-year Master of Engineering degree, which is kind of aimed at professionals who want to broaden their skills and try something different. And so that degree was, they give you freedom to choose different types of courses that you're interested in. And and it was very challenging. I would like to say, one thing that when you start a new level of education, sometimes the level of challenge is a lot more than what you had in your prior years. I'm sure your students have seen that also, going from middle school to high school, or high school to college. You're always the new kid in any new situation that you're in, and that doesn't really change. As you all probably know that, as being a new teacher or trying something new. As adults, we're always getting into a new situation, and we're still the new kids sometimes.
Every year it's like a whole new starting all over. It seems like.
To liberally modify the Navy SEAL phrase, the easiest school year you have is the one you're currently in. So,
sure. Yeah. So, like the no easy day. Like sometimes you have the easy days, but I think more often, if you don't want you want to have the appropriate challenge level. If it's too easy, anything you do, you don't want it to be too easy, because then you're not growing. And so it's important to challenge yourself. And to be honest, when I was working on my master's degree, I had certain days where I wasn't sure I was going to finish. I was really, so right. I'm sure your students relate to that sometimes. They're, they probably get discouraged sometimes, and we all do. And that's, I think that's a normal part of any, you don't want that too much, but.
Well, I think that's been like an overarching theme when we talk with people who've chosen engineering as a path, like especially even some of the younger students that we've spoken with recently, who just say, gosh, there's a point where like it may take longer than you expect, and that's okay. Or those days where you're like, I might have to quit. But if you're not experiencing that, then you probably aren't pushing yourself to be growing. And Sure. I think it's a really important thing for kids to embrace early on, the idea that if I'm not having something hard to work at, then I'm not on the right path.
Right.
Sure.
I would add that I think the important thing, and maybe you can speak to this as an engineer, is it's important we find ways at the university level that we don't lose kids out of the STEM pipeline. Just because It's harder, we need more tools for that frustrated student to get more help, not lower the rigor. I never like lowering the standard, but maybe provide extra opportunities and tools to recognize, hey, these kids that struggle, especially, you know, if you think about it, not many people in my family had ever gone to college. So when you go to college, if you're not from a family, like your dad was an academy grad, I have no doubt you learn discipline, routine, you know, perseverance. That's just built into your DNA, right? But kids that are new to college, they have a whole unique set of, they didn't have role models, maybe. That I feel like that's a good area too. I want to fast forward just a moment. You graduated early on in your career. You did something called the Mars Desert Research Station. Would you share a little bit about that and some of your takeaways from MDRS?
Yeah, for sure. Anyone who has, so first of all, I would encourage your students to try out the Mars Society conference. In addition to they probably know about the ISDC, which the NSS runs, but the Mars Society, anyone who's interested in Mars, there's the annual Mars Society convention. They did it online last year, and I believe this year also in October they had it. So the Mars Society runs the MDRS research station. It's out in Utah. I think it's been for a number of years they've run that. It's a Mars analog station. So it's used, it's a landscape that's representative of Mars that, so people go there and teams go there and do real scientific research. And they do it in a simulation. We call it in-sim. So we're working as if we are astronauts living in a habitat on Mars. And so there are rules. You don't leave the habitat without your spacesuit. They're analog spacesuits. They're not real spacesuits. They're meant to represent the, the time it takes to put on, take off that gear. What they really do in Utah is keep you cool so that you're not sweating too much in the desert.
and don't you lose a lot of dexterity because you're always in some kind of gloves that prevents you from having the ease with which to access your tech?
Yes, we had that. That's part of the simulation experience of trying to learn what are these issues that astronauts would deal with. And it's helpful. This isn't the only Mars analog station. There's others around the world, but they use the MDRS to learn some of these things, but also do real research. Our team helped with geology studies. Most of the teams there are doing geology studies on the landscape there in Utah, and or they'll test team dynamics, ideas about how to manage the team, and what are just to learn more about what it would be like for astronauts on a mission on Mars. There's a time delay. There's a mission support group who's remote that supports the team there. But they add the communication delay, which is involved with talking to someone on Mars. So we had a delayed round trip communication loop, which you would deal with on any mission to, at a distance from the Earth. So they do that, and part of my responsibility on that trip was to maintain the equipment and help with the experiments, and so it's definitely it's a very positive experience. There's I think it was a 2-week rotation when I went there. So I definitely encourage any students who are interested. I'm not sure how much students go on those crew rotations, but they do have student programs. Like there's a rover challenge where you build and test, compete with your rover that you've built to accomplish different tasks. And so yeah, the Mars Society has some great programs.
That would be a great one. I was kind of whispering under my breath to Kevin there about the rover one, because our high school students, and now one's off to college, but that has been one of their long-term projects, is the idea of how to take this CubeSat technology that they've kind of been working on for some time and turning it into something that would be for a lunar rover, actually. So
yeah, I think that is definitely worth doing. Like the CubeSats I don't know a lot about CubeSats, but I can imagine using them for a lot of different purposes.
Yeah, they are able to not only do good science, but I really think the most valuable role they play is a tool for education. It's all
Sure.
about, and you know this world, it's always about compromise and, trade-offs. It's always about optimization, right? In the
Right.
real world, it is always the iron triangle of scope, cost and deadlines, right? And
Yes.
and then functionality, capability, and that sort of segues us into. I'm going to summarize what you do as analytics, okay? And that may or
Sure.
may not be a good term. Share with the young kids what is the world of analytics, and if you can give them some examples of how there are good careers for STEM folks or engineers, mathematicians, physicists in analytics.
Right. Yeah. So the work I do is several different jobs have been about, as you say, analytics. So looking at what is the data available to you and what are the goals of your program. Whoever is sponsoring your work, they have some interest in goals they're trying to accomplish, which is engineering in general. You're trying to solve a problem using different types of technology, and data is one of the assets that you use to solve problems that you're working on. And so analytics is how you take that raw data and convert that into information, knowledge, wisdom that helps you solve those problems. And so that's just in a nutshell. And so along with analytics comes what we call systems engineering. So you're looking at a system as a whole and how well is it performing? Is it accomplishing the goals that you want it to? How do you know that? So your students have worked on CubeSats, and so they have to, any system that you're designing, you need to test it to understand how well it's performing before you launch that CubeSat. You need to test it, look at the data. So you're collecting some test data, and you have to do some analysis on that data. And so that's analytics, is taking that data and finding insights from that data. And so so data science is another term that people use. So what is your data telling you? How can you leverage that data to accomplish goals?
Right.
So that's kind of in a nutshell what I've done in my past few jobs.
Let's say you're working on, let's take a general scenario. Let's say someone's working on a new engine or a motor or some vehicle that flies, helicopter, jet, rocket, whatever. Have you ever done some analysis and said, wow, we really need a different kind of sensor, or we need a different set of data? Have you ever gone back and said, if we only had this piece of information, we could better meet whatever objectives we were challenged with? Do you ever have any experiences like that where you said, oh, if I only had this other column of data in my spreadsheet?
Yeah. So often you find, making sure you understand the limits of your data is important. So right, as you say, you may not have as much data as you need. It may be the accuracy of your data is not good enough. Like you may need data that's more frequent in time, or something else like that. You may need, there may just be something missing from your data. And so that's important to understand. Whatever conclusions you come to from your data, you may have to put a footnote on it, or a caveat, we call it sometimes, to say, well, here's what the data is telling us, but this is the limitation. And so lots of times one of my jobs involved looking at air traffic data for the FAA, projects for the FAA. And so there's always limits on the data that's available to you for various reasons. It could be, for security reasons, certain data is not available to you, or the data just hasn't been collected. So sometimes you have to go back to your sponsor and say, here's the conclusion we came to with the data we have, but it would be better if we had this other type of data. So you have that conversation with your sponsor sometimes. And we have certainly had that issue where we do the best we can to answer the question that we've been given, but it's just important to understand the limitations of your data sometimes and not make assumptions. or if you are making assumptions, make sure those are documented.
Right,
so
right.
here's what I've assumed in my analysis, and could there be something else going on? Maybe it's possible, but yeah.
I think that's important to note, that I think a lot of times students, assume that data is indicative of the answer, but what you're saying when you're talking about the limitations of data, I think that that's something for them to important to understand, that it's not going to provide necessarily all the answers. It's just a subset. It's just a piece of information, and something that, you can extrapolate and do many more things with.
Yeah. I think the parallel is knowledge versus wisdom, right? Data is just knowledge. What you do with it, yeah, definitely. I want to pivot real quickly to you've worked with the National Space Society. You are a space ambassador, and can you share maybe an experience from ISDC, or I know you've done some congressional advocacy, maybe your because of your professional career you've chosen some of the advocacy or outreach or some of the professional groups. Would you share just a little bit about any of that you'd like?
Yeah, so Right. So going to the ISDC conference it's a great place to meet people. I really, getting involved with space ambassadors, I believe I learned about it at ISDC. So going to these events is a great way to learn about opportunities. And so I definitely suggest that your students do that when they can. And I also, at the Congressional Visits Day, I met some people who helped me learn about some job opportunities also. And so that was, it's a side benefit. You're trying to accomplish a goal by visiting your member of Congress, but you may meet people also. So that's, it's a side benefit.
Networking, right?
Yeah, I think we actually spoke when we were doing a little conversation. I think we discussed the fact you're only as strong as your network.
Sure.
Right? So having a great network there's lots of benefits there.
Well, I want to ask a quick question about NSS. So there are a lot of societies out there. There are a lot of different groups. So why the National Space Society versus any of the others?
Right. Yeah, I'm not sure how I got involved. I think it was so I first got involved with the Mars Society a few years back, and then some people I met through the MDRS project I was telling you about. They mentioned the NSS. And they mentioned the Ad Astra magazine and the ISDC conference, and that's how I got involved. Was just a recommendation from people.
It's a nice magazine. Yes. Like seriously, it's a very good quality.
That was a great article, by the way. For those of you listening on a podcast, I just held up the magazine. Happens to be a computer, and they're contrasting Starship to SLS in this article, which I thought was fantastic.
That one's sitting on my counter also. I have to read that one sometime.
For the listeners, Eric mentioned the NSS ISDC. The NSS is National Space Society, open to the public. The ISDC is their sort of premier annual gathering, the International Space Development Conference. Yes.
Isn't that the ones our kids attended that year in California? And then they did that Spun Debate came from that as well, right? We work with Francis DeLutri also on the space universalization debates that are part of,
that's right.
Competed there. So it's a small world, right?
And as educators, for educators out there, they have a number of great student competitions. In addition to the debate that Shauna just mentioned, I have student teams that have competed in the space settlement contest for years.
Oh, that's right. It's the same. Yeah, that's how we ended up going to.
That's why we go to the conferences, because the kids, when they place, and this is a worldwide competition with like 15,000 teams, when they place, you get invited to come and present your winning entry at the conference. And that's how we go with students, is because we placed.
Right. It's been a good travel opportunity, as they say.
Yes.
Yeah, I was at ISDC a few years ago, and it's great to see all the posters. They have the poster competition, and people present their space settlement designs. And so I listened to some student presentations when, you walk by and they'll flag you down to give you a 5-minute presentation. It's great. It's a great speaking opportunity for students to speak to an audience outside of their school. I think that's very valuable. Learning to speak is important also.
Absolutely.
It's a skill where, all of us as professionals, we're constantly trying to improve that skill. it's a soft skill that's sometimes soft skill, meaning a non-technical skill, something that's helps you in your career to accomplish more. Given your technical skills, you can accomplish more if you're able to communicate better. And so it's always good to take those opportunities. And I think that's the speaking opportunity. Practicing speaking has been important for me.
We're super big fans of what you just said.
Yeah, that's true. I'm the talkie side of the techies and talkies.
Yeah, we actually call it the talkies and the techies, right? You're a double threat if you're very technically competent and articulate, just as you said.
Yeah, that's always the joke. Like, how did an English/debate coach get involved in space? And I was like, well, sure. How else do you know they were talking about it? As we kind of get to the end of our time here, we always wrap up, asking for some general advice for our listeners. So, if you were to give the top pieces of advice for students who might be heading into this career field, or just anyone listening, what would you tell them?
I would say. So I thought about this after I talked to Kevin yesterday. I think one thing that I learned later in my experience is that the working with a team is important, and learning to work together is really important. So it's and realizing that you can do a lot as a talented individual, but if you're able to work well with a team, you can do a lot more. So that's an important thing to remember. I think, as a student, you are working on your own. You're graded as an individual often, but you not all of us have the experience of working as a team as a student at the middle school or high school level. So it's great, your students are involved with these projects. I think that's a great experience to learn teamwork. That's important also. So I would encourage students to focus on learning teamwork. I would also, I think, remembering that. So a side corollary to that, side note, is that the people you're working with they will not be exactly the same as you. And it's good that they have, we're not all clones of each other. And so that's where we can leverage each other's strengths. So you're not going to know everything, and your coworker or your team member, they don't know everything either, but together you can do a lot better. So it's important to remember that we can help each other. And you don't, as an individual, you don't have to know everything in order to accomplish something. So
tremendously good advice. Tremendous. Yes.
And as a same thing as an adult, any team that you work on, there's research that shows even the most talented individuals, they can still benefit from working on a team. They don't. You can always benefit from someone else helping you and working together on a problem.
Well, it's important for you sometimes too to realize that that we're completely different here. That doesn't mean that my way is necessarily better than this person's way. It's how can we figure out a way to work together to create a single task, a single goal. Right. And that I think is a good lesson.
I think the best leaders in the world find people that are much smarter than they are and convince them all to work together. I think that's when you've hit the gold is find the smartest people you can, figure out a way to get them all to work with you. That's it.
And I think another thing to remember is don't be intimidated by people who are more talented than you.
Absolutely.
If you are the smartest person in the room, that's not always the best thing.
You need a different room. Yeah, very good.
That's a great way to end this. Thank you so much for spending your time with us this afternoon. We really look forward to our students and our listeners to hearing your advice as well.
And I hope to run into you live. We do at the ISDC coming up soon.
Yeah, I'm hoping to be there at the ISDC. That'll be great.
Wonderful. Thank you.
Thank you, guys. Good to talk to you.